Welcome to Werks. I hope you enjoyed today's video, and if you do, please like, subscribe, and comment. Today's video is on my modification to the CO2 laser lens tube on my blue and white laser engraver. There are many dangers to doing this, so take any and all precautions that you can to ensure your own safety, and don't do this modification unless you know exactly what you are doing. You are responsible for your own safety. Here's a quick view of the stock laser lens tube setup. This is a view of the pass-through on the laser. The machine has a pass-through for materials that are bigger than the laser bed in the y-axis direction. The laser lens extension tube only extends a certain distance and cannot focus a lens to the proper focus distance to the material and use the pass-through. My solution is to make a laser lens tube's extension that will allow for more adjustment of the focus distance of the lens and allow for the use of the pass-through on the machine. The machine I have is an Orion Motortech 50-watt CO2 laser engraving machine, 12 by 20 inch CO2 laser engraver cutter, and I use Werks software, but I'm starting to explore the Burr software. I use 6063 aluminum round tube that is 16 millimeters on the outside by 12 millimeter inside by the length of 300 millimeter, and 300 millimeter length of 6063 aluminum round with a 19 millimeter outside diameter and a 16 millimeter inside diameter. I also use some Scotch-Brite for polishing and removing powder coating from the stock laser lens tube. The first order of business was to determine the measurements of all parts associated with the laser lens tube extension. I first set up the laser for a stock condition for a 2-inch lens by measuring the distance between the laser lens nozzle and the material, commonly referred to as focus distance, with my own focus gauge. I then lowered the laser bed and extended the laser lens tube to the lowest position possible. I then set the focal length of the laser lens tube for a 2-inch lens. The next step was to lower the laser bed to determine the length of the new laser lens tube extension needed to be. After making the measurements, I disassembled the laser lens tube. I set up the 19 millimeter diameter aluminum tube in the lathe to cut what I'll call the connector. I made the connectors 35 millimeter long to make sure the original laser lens tube and the new laser lens tube would fit and be secure. I used Scotch-Brite to polish the ends of the tube. This wasn't necessary, but I like things to look their best. Lacking a proper cutoff tool, I used the right-handed turning tool to part off the connector. I then mounted the connector into the chuck and faced off and deburred the ends. After the connector was cleaned up, I started test fitting the 16 millimeter tube to fit into the connector. I was looking for a very light press fit. I will need to be able to remove the connector easily in the future. I also test fitted the original laser lens tube in the connector. I also wanted a light press fit on the original laser lens tube into the connector. The next part is the laser lens extension tube. I cleaned the new tube up by polishing the ends of the round, laying out the lining, and then parting the new lens tube off. With the new tube chucked up, I faced the ends, polished the ends, and deburred the ends. The original laser lens tube had a powder coating on it that interfered with the fit, so I used Scotch-Brite to remove the powder coating. I then started to test fit the connector over the original laser lens tube. After the parts were close to being finished, I started to fit the new parts together on the laser. I left things a little big because it's easier to remove material than it is to add material. Everything fit up with a little more polishing. I didn't extend the laser pointer because I plan on making another one in the near future. Here's a view of everything all fitted up. Here's a view of the laser running with the new laser lens extension tube. I will have to come up with an idea for a bed extension to hold oversized material when placed into the machine, or use a material roller lift, or come up with some type of hold downs to attach the laser bed. If you have any ideas or suggestions, please add them to the comments. I'm pretty happy with the results, and this modification will open up some additional capabilities for processing larger workpieces. Hope you enjoyed the video. Thank you for watching Werks, and I hope you enjoyed the video. If you did like the video, please give a thumbs up, subscribe for future videos, and comment. Thanks again.